Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my BEng Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. The 2017 question on coordinate geometry, there was two of them that year, question 3 and question 8. This is question 8 on paper 2. The diagram below shows the triangles CBA and CDE. The coordinates of C, which is here, is 4.5, 0. From the diagram, write down the coordinates of the points A, B, D, and E. Okay, so let's zoom in. So point A, so always X before Y in the alphabet, X before Y when you're writing down points. So A is over one box and down 2. So if that's 2, this must be 1 on my x-axis, and then down to -2 on my y-axis. So over 1, down to -2. Okay, so 1, -2. B is 4 on my x-axis, up to 2 on my y-axis. So 4, 2. Okay, it's like positions on a map. So D is 6 on my x-axis, look at that, down to -6. So 6 -6. And then E, where's that? That's 15, 6. So 15, 6 is E. Show using slopes that the segments AB and DE are parallel. Okay, so AB, which is this line here, and DE are parallel. Right, if it's a coordinate geometry question like this one is, the easiest way to show parallel lines is to show that their slopes are equal. So slopes or slants, so slopes equal, it's hard to see, for parallel lines. Okay, that's the piece of theory we're going to use to show that the line segment AB and DE is parallel. Okay, so I'm going to just split the page. So to show that a line is parallel, we're going to use slope. So page 18 of the log tables, you can see a formula for slope. M is equal to y2 minus y1 over x2 minus x1, and they always use m for slope. Okay, let's do AB first. So A is the point 1 minus 2, B is the point 4, 2. Okay, label him x1, y1, x2, y2. If you forget how to label points, know that it's here, x1, y1, x2, y2. Okay, and then we're going to sub them into here. Okay, so that we get slope M being equal to y2, which is 2 minus 2. So 2 minus 2 over x2 minus x1. So for that I get 2 minus, so minus by minus is a plus, so 2 and 2 is 4 over 3. So the slope of the line AB is 4 over 3. Okay, it's a positive number. I like that because when I look at A and B from left to right, it's going up a hill. So I would expect it to be a positive slope. Okay, let's have a look now at DE. So D is the point 6 minus 6. E is the point 15, 6. Let's label them x1, y1, x2, y2. Okay, and let's sub them into the exact same formula again, the formula for slope. So slope is equal to y2 minus y1 over x2 minus x1. So I'm getting 12 over 9 for that. And if I reduce that down, and you can see that 3 divides into it, Or if you can't see that, don't be afraid to put 12 over 9 in your calculator, and your calculator will give it to you in its simple form. Okay, slopes are equal. This line is very important because it shows that you understood the question. Okay, without it, one could argue you haven't answered the line, or you haven't answered the question. Now this line of text does help. Slopes equal for parallel lines. So slopes are equal, therefore give them back their own English. AB and DE are parallel. Okay, so that's that one done. Okay, C said, show that the area of the triangle CBA, so CBA is this little one here, so show that that is 4 square units. Okay, to get the area of a triangle, I'm going to use this one. That's a half x1 y2 minus x2 y1. Now this one you wouldn't have done in your junior cert. It's more of a leaving cert one. So area is equal to a half of, which letter comes first, x1 y2 minus x2 y1. Okay, the first thing you should note here is that there's just 2 points in it, x1 y1 and x2 y2. Yet a triangle has 3 points. Okay, it has 3 corners, 3 vertices. Which 2 do we use in area? Well, what you have to do is you have to move one of the points onto 0, 0, onto the origin, and then move the other 2 points by the same amount. Okay, so I'm going to just move A because it's the closest one to it. Okay, so that point is going to go there, B is going to go by the same amount, and C is going to go by the same amount, so that I end up with a triangle that literally moves to here. Okay, so you can see, if my diagram was perfect, that that is the same size triangle as the other one. So I've literally just shifted it up a piece so that one of its corners was on 0, 0. And then your new points here becomes your x1, y1, x2, y2 that we use in that formula. Okay, so how do we go about doing that? Well, let's move. A is 1 minus 2. Let's move him to 0, 0. Okay, which is the origin. So what do we have to do to the x coordinate? Well, we had to subtract 1 off that number there to bring him to 0. What do we have to do to the y coordinate? Well, I had to add 2 to the y coordinate to bring him from minus 2 to 0. And that makes sense because on the y coordinate I have to move up. So I'm adding on 2. And in the x coordinate I have to move back 1. So I'm subtracting off 1. Okay, and you do that to the other 2 points. So CBA, so B is 4, 2. C is, it gave me C in the question, 4.5, comma 0. Okay, so what you do in this is you go minus 1 off the x plus 2 off the y. Okay, so that you end up with going 4 minus 1 to give me 3, 2 and 2 is 4. C, I have to do the same thing, minus 1, I have to move them all by the same amount, so that I end up with 4.5 minus 1 is 3.5, comma 0 plus 2 is 2. Try not let the fraction bother you too much. Your calculator is there to help you do the maths with it if you don't like the fractions. Okay, and let's label these x1, y1, that's my first point, and x and y of my second point, x2, y2. So that area now becomes a half of x1 by y2 minus x2 by y1. Okay, I'm just going to check that because it's easy to make a mistake. So x1 by y2 minus x2 by y1. And I did make a mistake. I put in a 3 instead of a 4 here. Okay. All right. You put that into your calculator. So I'm going to put in, when the letters are written like that beside each other, it means multiply. So on my calculator, I'm just going to go bracket 3, bracket 2, minus bracket 3.5, close my bracket, open my bracket 4. Okay, so I'm getting a half of minus 8. Okay, now you see these two lines that's down here on the area formula? They are called the modulus, or it means take the absolute number. So that means I essentially ignore the minus and I just take the positive. Okay, so that's why half of 8, I'm getting 4 square units, or 4 units squared. Why was it minus in the first place? Well, when I moved my triangle over here, majority of it was over here in the negative area, because if you think about over here, I have -1, -2, -3. So that's why I ended up getting a negative area, because my triangle was over there. But if you think about area, whether it's positive or negative, it's just area. It's how much surface space it takes up. So that minus that's here just more gives me the location of the triangle rather than anything got to do with its area. So in some things in maths, we ignore the sign and we just take the positive units, and an area is one of them. Another place we do them is the length of a line. You can see the two same lines around the length of PQ, and again, that's because we only ever take positive differences. So if I asked you what was how many miles between Dublin and Belfast, you might say 200 miles. I might then ask you how many miles between Belfast and Dublin. Well, technically speaking, it would be minus 200 miles because you're going backwards. But we don't take the minus, we just take the number 200. Okay, so that's that one. So that's done. I have shown that. And QED is Latin for proven. Okay. Find AB, and you have to know that that means the length of AB. You can see it here written beside the length, but don't get caught out with that one. That means the length of AB, or the distance from A to B. That's the same thing. So again, if I'm finding the distance between A and B, I take down the points A and B and I label them x1, y1, x2, y2. And therefore the length of AB, I'm just writing down this formula here. It's quite a long formula. x2 minus x1 to be squared plus y2 minus y1 to be squared. Now try not get too intimidated by the formula because you have your calculator. Okay, so x2 minus x1 to be squared plus y2 minus y1, and watch, there's a minus there coming up. Okay, so if you put that into the calculator, you'll get 4 minus 3 squared plus 4 squared, which is root 25, which is 5 units. Okay, I'll just check that on my calculator. That's what I'm getting. Squared plus bracket 2 minus 2 all to be squared. Yeah, 5 units. Okay, so the length of AB is 5. Why do I use this units? Why do they use units? It's because we don't know if the distance between those points are millimeters or centimeters or kilometers, but whatever they are, the area of it is 4 units and the length of this one is 5. Okay, so there was more to that question. I just copied down the diagram again just to help us along. Let me write in some of the points. 1 minus 2. 4, 2. 6 minus 6. And 15, 6, wasn't it? Yeah, okay. The triangle CDE, so this triangle is an enlargement of the triangle CBA. Given that the length of DE is 15 units, Find the scale factor of the enlargement. Okay, so now this is no longer the coordinate geometry chapter, it's more geometry. Okay, and you'll find the questions towards the end of the papers tend to be longer and tend to mix chapters more, okay, which makes them that bit harder. So it's telling me that DE is 15 units. Now we worked out one of the lengths. We worked out AB, which was 5. Okay. So what I'm wondering now is that line is parallel to this one. We did that with slopes. Okay. I'm wondering, is the length of DE equivalent to the length of AB? So in other words, if CDE is an enlargement of CBA, then the triangles are similar. Okay, and similar triangles have the exact same angles, but their sides differ. So in other words, it's a blown up, CDE is a blown up version of ABC, but the angles are the same, okay, and that's important. So the scale factor then, how much times bigger is it? Is 15 over 3, which is 5. So it's 15 over 5. I was doing the sum in my head. 15 over 5, which is 3. So it's 3 times bigger, okay? And K is often the letter used for scale factor. Okay, use this scale factor to find the area of the triangle CDE. Okay, so this is quite a hard question. So the area of ABC, if you remember, was 4 square units or units squared. Okay, and as part of that geometry chapter and the enlargement section, the area of the enlarged triangle, which is CDE, is equal to K squared times the area of the original triangle, which is ABC. Okay, and watch out for this squared factor here. Okay, so it's equal to 3 squared by 4. Where did I get that? Well, K is the scale factor, which we got to be 3. And the area of ABC was 4. So 3 squared is 9 fours. So it's 36 square units or units squared. Okay, so that's how you use the scale factor to find the area of the enlarged triangle. That K squared is the link. Okay, so that's what that question meant. Use the scale factor to find the area of the triangle. Remember, how did we get the scale factor? It's not 15 minus 5, because similar triangles, their sides are in proportion, or they're a multiplication of each other. Okay, not an addition. Or of course it could be a shrunken triangle, but this is a bigger one. So the scale factor, it's 3 times bigger, and the area then is 3 squared or 9 times bigger. And that concludes the 2017 question.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.